Yo, everyone, welcome back. In this video, I'm going to do an educational discussion on the Cosmwasm. You guys know me, I'm a big believer of the Cosmwasm. I'm going to be doing an in-depth breakdown in this video, including sharing some awesome clips from the creator himself. Also, I'm going to be discussing the Coreum Airdrop. The Coreum Airdrop has officially started, so it's going to be a fun episode. I'm going to be reading this article written by Sebastian, the 2023 Interchain Thesis exploring the biggest trends and opportunities in Cosmos. So I'm going to be reading the specific part just on the Cosmwasm. The entire article will be featured in the description below, so make sure to check out the link if you want to learn more about the Cosmos. I'm a big believer in the Cosmos ecosystem in 2023. The secure by design smart contract VM is quickly gaining traction in the Cosmos ecosystem and beyond, attracting new developers. Cosmwasm was created at HackAtom in Berlin in 2019 and has since become the de facto smart contract VM used by Cosmos SDK chains. At its core, Cosmwasm is a Wasm implementation as a Cosmos SDK module, meaning any Cosmos chain can enable robust smart contracts written in Rust. Wasm is highly optimized virtual machine with little overhead. This makes it the logical choice for blockchains where computing constraints are high. Polkadot implements Wasm-based VM for its substrate framework. And for a brief moment, there was discussion in the Ethereum community about Ethereum-flavored WebAssembly. Though Solidity is truly a success story in terms of adoption and value created, it carries issues inherent to the language and the construction of the EVM. From a security perspective, Cosmwasm eliminates reentrancy attacks, which has been responsible for billions in lost funds, notably the DAO and the Parity Multisig hacks. We just seen a DAO on Alliance Block get hacked. So this is where Cosmwasm eliminates that issue. As contracts are written in Rust, a typed language with industry-leading testing suite and robust tooling, it provides solid test coverage to critical business logic. In other words, Rust development environment dramatically reduces the risk of bugs and common vulnerabilities being compiled. Another powerful feature of Cosmwasm is contract upgradability. This migrates functionality allows for an optimal admin key capable of upgrading contracts. Coupled with multi-sig account, contract upgrades can be made subject to a community vote or an agreement. In contrast, EVM-based dapps, decentralized applications, must implement suboptimal proxy and library contracts to deal with upgrades. One of Cosmwasm's biggest strengths is that it was designed to be IBC-enabled, meaning it could send and receive assets, messages to and from other chains and Cosmwasm contracts. These powerful features enable new forms of cross-chain composability accessible to any Cosmwasm developer. The true power of Cosmwasm lies in its ability to serve as the platform for innovation in the Cosmos ecosystem. Deploying Cosmwasm allows teams to rapidly prototype, implement new features in hours or days rather than weeks or months compared to building custom Cosmos SDK modules. Several chains have added permission Cosmwasm, relying only on SDK modules for low-level functions like token transfers, governance, and staking. Osmosis, Stargaze, Kai are chains that heavily use Cosmwasm in this configuration. To push things further, in the direction of rapid prototyping and ease of development, a fully Cosmwasm-based SDK is in the early phase of development. Although still far from production readiness, CW-SDK would entirely replace the need for the Cosmos SDK. This is huge, guys. Several permissionless Cosmwasm chains exist. Examples, Juno has attracted a community of hundreds of developers and dozens of teams building innovative decentralized applications with Cosmwasm. Notably, DAO, built on Juno, is becoming the de facto DAO tooling suite for the interchain, and it's rapidly growing in features and adoption. Archway is a Cosmwasm chain exploring novel designs and protocol economics such that the application developers generate revenues on chain. So here are some of the Cosmwasm projects. Coreum uses Cosmwasm, one of the projects that we've been covering for the past year. In the last 2 years, more than 20 Cosmos chains have implemented Cosmwasm. projects are also porting into other ecosystems. Composable Finance is building the first generalized Cosmwasm VM outside Cosmos. The number of Cosmwasm themed hackathons is growing, with at least 3 taking place in 2022 and more planned for 2023. They have a bunch. I know about Wasm is coming up. Wasm Academy is a free educational platform provided by the key maintainers of the project. It's also attracting a new smart contract developers and enticing its third cohort. The speed of development, security, ease of maintenance, and modern designs combined with the quality of breadth of Rust learning materials are solid arguments for developers to adopt Cosmwasm. As more liquidity enters the interchain, we're confident the number of Cosmwasm developers will continue to grow, inspiring a new wave of innovative, decentralized applications. This is the article. This is the section on Cosmwasm. He has a dive deeper into the topics of Cosmwasm below. You can find these links in the article. But I actually cut out some clips, just short clips from the discussion with smart contracting platform for Cosmos with Ethan Frey. So I have about a 9-minute clip I'm going to show after this video. Then understanding Cosmos-Wasm SDK with Larry Engineer. There's a clip where he describes basically WebAssembly that I'll show you. So this is more of an educational video. You guys know me, some of my favorite projects that I talk about in the Zen Lounge. Juno, known as the neutral home of the Cosmwasm. So it's the home for Cosmwasm. And then Coreum. We actually have an airdrop that has started today for Coreum. Also uses and relies on Cosmwasm. So it's important to understand the underlying technology of what I'm personally invested in. That's why I make these videos. So the core airdrop has started. You can see it's going to take, at least probably 48 hours for it to appear in your wallet if you got big bags. Right now, they're only distributing tiny little specks of dust of core. But guys, hopefully you enjoyed this article, this snippet, and enjoy the clips after if you want to learn more about Cosmwasm. Got some exciting things cooking for you guys, and I'll be sharing real soon. See you next time.
Out. And what I really see as differentiator and what I want to work on and what I am working on, besides like helping people, building tools and tutorials for people, is IBC. So interchain contracts. It's like I did this in Seoul and the HackAtom. I demoed it and some people hacked on it, and like Jake did some and some guy from Taiki from Japan did another one. It's pretty awesome that you can basically deploy a contract on 2 different chains. They talk to each other with like no trusted bridges, no multisigs, nothing can be hacked in the middle of them. Just like pure guaranteed message passing with complete security of IBC. And the contract just hold the app logic. Like if you send a message that says mint token or mints token or not, I don't know, or make a governance vote or control this DAO or change the threshold of my LP pool thing or whatever you want to do. It's kind of like interchain accounts, but like so much more powerful because you can actually write contracts on both sides. And that was not possible until you actually had multiple important chains running Cosmos 1.0. And we were waiting for like 3-4 months ago. It was like, actually, okay, great. Like Juno, Secret, Juno's Moses are now 1.0 and Secret's upgrading very shortly. And I think those are 3 of the top chains behind the hub on the ecosystem in terms of market cap, at least. And they're all running it. Injective also is another big chain. They're also running it. So like a lot of people are running it now. So most of the chains that has the hub are running Cosmwasm, which means you can actually build a protocol that spans 3, 4, 5 chains using IBC messages and write an entire, not just your app logic, but actually the protocol communication there. That's like writing your own API servers and talking blockchain to blockchain with like no bridge hacks involved. And that's really where I see the future. And that's really where I'm going to put a lot of work into not just building it, but also documenting, trying to explain it, but also trying to build these things out there because, hey, I'm trying to build something that doesn't exist yet. So it's hard to teach people tutorials something that doesn't exist. So I got to build this stuff first and then show you how to build it. But I've just built some prototypes out there and it's amazingly fast.
So I think one thing we did talk about before on this podcast, maybe some people have heard of or are aware of, is in Cosmos, this concept of interchain accounts, which basically you have like an account on one chain and then you can control it from another chain. So let's say, for example, there's a project Quicksilver, right? And they're doing liquid staking with that. So that this Quicksilver chain can control an account on Cosmos. It can a Cosmos Hub. It can stake atoms, vote in governance, claim rewards, do all those things, and then but it's controlled by another blockchain that could then issue like a liquid staking token. So that's like an example of interchain accounts. There are obviously many examples. Now, what you're describing, right, is basically goes even a step further, right? Because you basically have like contract code on both sides. Whereas here it's kind of like, let's say in the Quicksilver example, it's kind of like contract code on the one side, right? And then on the other hand, it's just like a normal account. Can you talk a little bit about use cases? Like, what are some of the things that, you could, like, you'd be interested in building, or you can imagine people building, these cross-chain Cosmwasm apps?
Yeah, I will. So I think in some theoretical way with token transfer and interchain accounts, you may be able to build anything, may be able to. And interchain queries, if you add that, like those might be fundamental principles. Say these are holy principles, we can build anything with them. But they're inefficient to build a lot of things. So I think for staking is fine because you don't have to stake that often, right? Like you can just every 12 hours, maybe pull out your money and restake it, right? It doesn't have to go so much. But let's say I have a lending protocol that's liquidate and DEX on another chain, right? The current way of, let's just say this, just right now, the existing protocols, assuming these all exist, interchain accounts, interchain queries, and token transfers. If I have a protocol here that wants to liquidate on a DEX over here, right? First, I move one message, move my tokens over here. I wait to get a response. Right now, you actually don't get a callback on the response. So you need a DAO to control it. And we're working with the IG team to you actually get triggered a callback when it finishes. Then you say, okay, now make a swap with this interchain accounts to make a swap of that money to send over here for the other token, right? It may have succeeded or failed. If it succeeds, then I query to see actually how much did I get, right? The full amount I got, okay. Then call over here interchain accounts, you transfer the tokens back to get the tokens back, right? And that's a lot of here, make a request, get a response, make a request, get a response. These are all slow requests, right? In here has orders the whole thing. Now let's say, hey, this is actually a common use case. This is not something you do once. This is something you're doing all the time. It's your business case. I want to deploy that, optimize that. I want to deploy a contract here and a contract here that what they do say is they have their own protocol, which is move tokens, swap them at this price, and send me all the results back. If you don't make that price, if the money is too low, right, the price is if the market won't trade at this price, they return my original funds back, right? That's a really simple logic. A lot of people might want that. So, but we're not going to wait for Go code 6, 8 months, 12 months to build some new Go logic with this very specific use case integrated into some DEX on this one chain. We say, no, we want to launch it now. So we could do it now. I wrote a query right now. We could do this very quickly. And basically say this. Now we write these two contracts here. They do that. If you trust it, someone else can say, okay, here, liquidate at this price. It will send one message back, and then you get a callback, whatever, one IBC message. It will do this logic. And then you get a callback saying, okay, I liquidated this price. Great stuff. Or I failed to liquidate, and here's your money back, right? Like you get it right away. That I think will allow people to do integrations that you couldn't even conceive of. That's faster, right? This is faster, but then actually under conceive of, I'm gonna go one more. So I'm working on something called WYND-DAO, WYND DAO, and I think the second stuff might be that first one I'll throw as a demo. I'll throw as a prototype and give it to y'all. It's free stuff, right? We'll be doing this for you, everyone. I have a query uses IBC price oracle osmosis is implemented. I'm waiting for TWAP out there to be finalized. But the next one is this. I think is the next level of really deep integration. So imagine you have a DEX on one chain, and you want to make another DEX on another chain. That DEX wants to launch a subDEX on another chain, right? The subDEX is its own separate liquidity, right? So it's going to have its own issue of liquidity, and it's going to be small. It's not really that popular. But actually I have all liquidity on the other chain. But maybe I could actually not make a generic protocol that works for anyone, but I will make a special contract between my sub-parent DEX and my child DEX, which is like a permissioned IBC like an encrypted or authenticated IBC connection that just runs from my parent DEX to my child DEX, right? And I will move 1% of my liquidity over here, but I will keep the entire price information of all the rest of the liquidity over here. So here's actually the reference price. The reference price is here, right? And you actually have the full reference price here, and that's actually what you use. Over here, you'll assume that you have that value, and you can trade a little bit of liquidity very quickly, just like an ATM or a branch bank. And so maybe it's a minute out of date of the actual price over here, right? And so you have a little slippage here. You can maybe, but you only can move a 1% liquidity. You only can pull a little liquidity out here. You can't pull too much out anyway, right? Like you can't pull too much over here. So if you run in it, you run in it, and then it gets a new price update. But in the meantime, while things are not moving too heavily, you basically get immediately access. You don't have to call IBC swaps. You get immediate access like a local DEX, like immediate swap response right away, immediate responses from a DEX locally, with the same liquidity effectively as the parent DEX. So they've basically shifted this as a branch bank that's able to provide virtual liquidity at much higher amounts and still safeguard against bank runs, which I think is pretty amazing. And like this idea of like protocols are not just like copying themselves over chains, or they're just like, okay, we're like kind of like something like that, like we just moved collateral over chains, but actually like integrating operations over multiple chains is, I think, a revolutionary concept that no one has really grasped or able to build out yet. So I think one project I'll be doing besides knocking stuff out, like, here's how you swap on a Juno Osmosis, swap on the Osmosis DEX from Juno with an IBC message. And, this has been in discussion for a while now, since Lisbon. And besides that kind of stuff, I want to work on basically building out next level integrations of multi-chain applications that are truly multi-chain, that live on multiple chains and like balance banks between multiple chains.
Thanks so much for that explanation. That is very cool. And it's just amazingly powerful, right? Like that's where you really see the kind of like multi-chain. I mean, already the Cosmos ecosystem has had such an explosion of activity, and we've seen IBC be so powerful just with token transfer. And I was always the thing that shocked me the most with IBC, or surprised me the most, was just like how actually good the user experience was. I think Osmosis did like really great job at that, and I mean not just Osmosis, like others, but now I think having all of these more advanced things, right, with more powerful IBC stuff, with Cosmwasm, it's going to be really like weird and mind bending, I think, when those come out.
For blockchains generally, like even though Ethereum hasn't implemented, there was some interest there, like other blockchains are using Wasm. Why do you think that is?
Well, Wasm is probably the single most optimized virtual machine out there. So virtual machines, meaning like let's say you have your physical CPU, and that CPU has an instruction set. So when you write a language, it compiles to binary instructions for that instruction set. A virtual machine is a container that runs on top of that has its own instruction set. And when you write your program, it compiles to binary instructions for that instruction set. And when you run in that container, it needs to be translated to your CPU instruction set and run there. So that usually is overhead because you have to have a translation step. So VM usually comes with overhead. That's the thing. Cosmwasm is Wasm is probably the most optimized VM out there. It has near native performance, meaning you run a program in the Wasm container, it's almost as fast as running it directly on your physical CPU.
So maybe just to explain here for those who are less technical. So when you write a program, let's say like in C++, or you write a program in like some language that has a compiler on your environment, you compile that language, it runs directly on the CPU, like through the operating system, but there's less layers of abstraction between your program that you're running and the underlying CPU that's processing, that's basically executing state changes. With a virtual machine, whereas where you're running a virtual machine on a blockchain, there is some layers of abstraction there that exist between the application and the underlying data structure that is being updated all the time. And because Wasm is so optimized, the performance of Wasm will be higher than, say, like an EVM, because the the virtual machine has nearly the same performance as whatever underlying infrastructure is there. So there's like a lot less compute overhead for that virtual machine to run its programs than something that would be less optimized. Is that a good way to explain it?
Someone actually told me Cosmwasm is more performant in the EVM. I forgot who that was, but that was a surprising result to me because EVM has a much smaller instruction set. Usually, the simpler a VM is, the easier it is to optimize it. So I always assumed EVM is the most performance VM out there, but then people told me Wasm was more performant. So that was a pleasant surprise.
Yeah, we also have to consider, of course, the instruction set, right? So like in Solidity, we have like a limited instruction set in terms of the language and what it is possible to write with that language. And then with Cosmwasm, we actually have like the full instruction set of Rust. Is it the full instruction set, or is it just
full instruction set of Wasm?
Of Wasm, right? Okay,
yeah.
Understood.
And almost everything in Rust, except for a few things such as floating points or randomness, can be compiled into Wasm instructions.
Okay. Okay, cool. Yeah, I think that sort of paints a picture of like what Cosmwasm is and like how it interacts with Rust.